Hello, we're going to start out right now with the next lesson, and that is lesson 4. We're going to be calculating probabilities for chance experiments with equally likely outcomes. So, we're going to start with a little experiment. We know that to find the probability of an event, we do the number of observed occurrences of the event that we want divided by the total number of observations. And we can write our probabilities as fractions, decimals, or percents. So, this experiment says that I start with a bag. Now, I didn't have a bag, so I've got this little box that I started with. I also didn't have colored cubes, so instead, I had a box of these. So I took 20 of these and labeled them with the first letter of the colors. So yellow, green, blue, and red. So I have a random amount in here. You can hear that shaking. So I'm just going to take one out. And it says that I will replace it. I'm going to record the outcome of my drawing. So that one's blue. And then I'll put it back. I'm going to do this 20 times, just randomly picking from here. Okay, so that one's got a G. So that's green. Okay, I'll do a couple more. Red. Well, that's fun. Okay, blue again. So I'll pause this and we'll just do it together. Okay, green. And then red. I'm putting it back in there and then just randomly picking again. Okay. Red again. Green. Red again. Red again. Okay, yellow. Finally got a yellow out of there. Red again. Let's get this down. Red again. Green. Red. Yellow. Red. Green. Yellow. And the last one, green. Okay, so I have completed my experiment. See what's next. Okay, based on the 20 trials, estimate the probability of each of these. So we did 20 trials. Okay, now I'll just go back and count. Blue, 1, 2. Okay, I got blue 3 times. Okay, green, 1, 2, 3, 4, 5, 6 times. Red, 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And then yellow was 1, 2, 3 times. And that was just my experiment. Now, if there were 40 cubes in the bag, how many cubes of each color are in the bag? So, how would we go about doing that? We did our trial 20 times, so what would we do to determine if there were 40 cubes, how many of each color there would be? So to determine that, what I'm going to do is switch colors, and I'm going to think about this. Okay, what if there were 40? Well, this is doubled, so I should double this. So about 6 would be blue. Also times 2 here, about 18 red. 12 green. 6. So for each one of those, what I did is I looked at the relationship between this number here, this 20 trials. Okay, what if there were 40 cubes, then how this total and that total. So how are they related? Well, this one is double. So I would double the chosen number or chosen color here, such as the blue. So if I had to think about how this bag is composed, like if I took all of them out, would you expect to have more of one color than another based on your results? Looks to me like it's pretty heavy red. So that could be true, or it could be that if the reason I'm not getting about the same, there could be different ratios of different colors, or there could be all the same color and I've just not done the experiment enough time for it to kind of level out. So, good things to think about. Now, if I were to draw another 20 cubes one at a time and then replace them, would I see exactly the same results? And no, because this is a chance experiment. Okay, we have random results. Okay, so here it asks us to actually find the fraction of each color of cubes in the bag. So I went ahead and poured these out and sorted them. If you're doing this at school, you'll have real cubes, but using what I've got here at home. So I've got 4 green. Color code this 4 greens. For the blues, 1, 2, 3, 4, 5 blues. Okay. Then, what color is this? It does look like I have more reds. 1, 2, 3, 4, 5, 6 reds. And then the yellows, 1, 2, 3, 4, 5 yellows. Okay, so you can see that there's a total of 20 cubes. They're not really cubes, but we're pretending. Use what you got sometimes. Okay, so the fraction of each color of cube in the bag. Got that. That's what this asked me to do right there. All right. Now, if I wanted to make those percents, I know that percent is out of 100, so I could really think about it this way. To get from 20 to 100, it's times 5. So I could multiply each numerator by 5 and get my percent that way. 20%, 25%, 30%, 25%. And if I add those up, all of it together, it's 100%. 50, 60, 70, 80, 90, 100. And it worked. Now, each fraction is the theoretical probability of choosing a particular color when a cube is randomly drawn. Okay, so we had the theoretical probability of, this would be theoretical, because in theory, if I did it 20 times, I would get these numbers. I would get 4 green, 5 blue, 6 red, and 5 yellow. But we don't live in theory land, we live in the real world. If we did the experiment enough times, the law of large numbers tells us that we would get closer and closer to the theoretical probability with an experiment. But it's not going to be, the theoretical and experimental are not going to be the same when you are doing an experiment. Okay, so is each color equally likely to be chosen? No, because I had more red and less green. I did have the same number of blue and yellow. Okay, how do the theoretical probabilities of choosing each color compare to the experimental? So when I did the experiment, let's see, I had the same blue and yellow. So I had the same blue and yellow. I had 3 instead of 4. I had a whole lot more red, but I did have more red. And then the green was more than the yellow, but less than the red. So it did kind of compare somewhat, but it wasn't exact, as we talked about at length. Moving on. Okay, here's an experiment. This is flipping a nickel and a dime. The first step in finding the theoretical probability of obtaining a heads on the nickel and a heads on the dime is to list the sample space. For this experiment, the sample space is shown below. So, here's the sample space. When you do the nickel, you could either get heads or tails. And when you do the dimes, you could get heads or tails, heads or tails. One does not depend on the other. There are 1, 2, 3, 4 possibilities. Or I have a sample space of 4, meaning that each one of these is 1 out of 4. So the probability for each of these events is 1 out of 4, or 25%, or 0.25 if I wrote it as a decimal, which is 25 hundredths. Now, the probability of 2 heads, or probability of 2 heads, is 25 hundredths, or 1/4. Now we're going to consider this experiment of rolling a number cube. The sample space, 1, 2, 3, 4, 5, and 6. Okay. An odd number, 1, 2, 3 out of my 6 are odd numbers, so that's 1/2. And then the probability of rolling a number less than 5, less than 5 would not include 5, so that's these 4 out of 6, which is 2 out of 3. Okay. Moving on to the next page. Consider an experiment randomly selecting a letter from the word number. What is the sample space? N, U, M, B, E-R. None of those repeated, so I included them all. If there were 2 E's, then I would only write E once. Selecting a vowel. Those are A, E, I, O, U. So there's 1, 2 out of 1, 2, 3, 4, 5, 6, which is 1/3. What's the probability of selecting the letter Z? There are no Z's, so that's 0 out of 6, or 0%. Okay, now we're considering another experiment, randomly selecting a cube from a bag of 10 cubes. Color the cubes below, so the probability of selecting blue is 1/2. So there are 10 cubes. 5 of them would need to be, I'm not going to color them all the way, 1, 2, 3, 4, 5. 5 of them would need to be blue. Exactly. 5 blue. I could leave these white, I could color them orange or different colors, just 5, exactly 5 need to be blue. Color these cubes, so the probability of selecting blue is 4 out of 5. So 1, 2, 3, 4, 5. Here's a group of 5. 1, 2, 3, 4, 5. Here's another group of 5. For each one of those groups, I'm coloring 4 out of the 5 blue, which is 8 out of the total 10, because I had 2 groups of 5. 2 groups of 4 that were colored blue. Okay, one last question here. Students are playing a game that requires spinning 2 spinners. The student wins the game if both land on red. What's the probability of winning the game? Remember to first list the sample space and the probability of each outcome. Okay, so we've got red or blue. Now, if